So in order for us to graph polynomials, we need to find the intercepts, right? The x-intercepts, the y-intercepts, and our stationary points. Your stationary points, be it a maxima or minima, okay, maxima or minima, or it is a point of inflection. And you will be able to identify what these turning points are if you are going to use the first derivative test. Okay, using your first derivative test, meaning you take your first derivative, equate it to zero, and then you will now get your maxima or minima. Once you get your maxima or minima, you test it again. If it is if you have a, what's this? An increasing function or a decreasing function. So you just compare both sides of the point and determine or draw out your conclusions there. Okay. And last meeting, I also mentioned to you or showed to you that instead of testing it using the first derivative test and then looking at the left side movement and the right side movement, you can take the second derivative test and you just look at the value that you are going to get. If you test a maxima or minima point, okay, using the second derivative test, you can identify it if it is a maximum or minimum. Okay, the conditions or these conditions are met. Number one, if the second derivative at that point is greater than zero, what will you get? If the second derivative test for that particular point is greater than zero, then what? It
It's
will now
increasing.
give you a maximum, no, greater than zero, minimum point. Second derivative, greater than zero, it's a minimum point. Second derivative, lesser than zero, it is now going to be a maximum point. Okay? If its first derivative, want to know if it is an increasing or decreasing function, in the first derivative test, if it is greater than zero, then it is increasing. If it is lesser than zero, then it is decreasing. Okay? So
Yeah, teacher.
do not, it is a bit confusing if you don't use it often. Okay? You will forget it. Okay. So now, I think since you already know the basics of your turning points and the points of inflection and the different first derivative is applying this in real world situations. Okay, so the question here is, let's say that we are a can manufacturing company. Okay, we make or produce cans. Okay, our specialty is making cylindrical cans. Okay, so here is the order. There is an order for us to make a can that can contain a volume of uh, 334 centimeter cube. Okay, we are being asked to make an order, okay, of a can that can contain volume is equal to 343 cubic centimeters. 343 centimeter cube. Okay? But then they said that the design is up to you. Okay? The size of this can is up to you. So, but as long as the can contain 343 cubic centimeters. So it's now going to give us a dilemma, or it's now going to what? we can make the design of the can based on longer, okay, long can like this. It can also be a short can, but bigger radius, right? Or we can also make a can like this. The idea here is, even if we change the shape of the can, the volume must be 343 centimeter cube. Okay, so if our company, if we are the manager, if we are the manager of that company, what will be your goal? What will be your concern here? Our
However, still the same volume,
best style.
or
Best
probably,
style.
Maybe
How will we
yeah,
know that
practicality.
it is the best practicality? Okay, I will go with that practicality. What do we need to do to be practical?
It needs to be easily stored.
Easily stored
Doesn't take
for
much space.
doesn't take much space, but you are thinking of the customer side. That's not our problem anymore. Think about the company. We are making this can. So what is our primary goal here?
make
Reduced
it
waste.
easily.
Our
Yeah.
use
Most
waste. Very
material.
good. So we need to use this with minimum amount of minimum amount of material. Okay, minimum materials. Okay, if you think about it, if we are going to just think of A4 size paper. Okay, if you're going to make a can like this, you are going to be cutting the circle there, cutting the circle there, and then the body is going to be very, very long, right? Very, very long, wherein you can only cut one particular size here. So this space over here is wasted, which means wasted amount of material equal to wasted amount of money, right? So minimum material, same is true. If you make it big like this, and if you're going to make it as an A4, you need a body like this, but then the circle is not enough already. You might be using two pieces and then cut the circles over here, maybe three. So wasted materials lagi. So what is now the most, okay? What is now the most efficient size, okay, that we can use in order to get or to produce the smallest amount of waste. Okay, so the things that we need to consider are the following. We need to consider the radius. Okay, we need to get the radius and we need to get the height of this. Okay, since the volume is 343 and we are also concerned with the area. Okay, so what is now the web of this one, of a cylinder, right? You need two parts. You need the body and you need your covers on top and below. That is if you cut it like this, right? So basically this is now the height. This is radius. So what is this distance over here? Okay, what is this distance over here?
Circumference.
Circumference of the circle is 2 pi radius. Okay, so we are now analyzing the problem using two different what's this? Two different units of measure. One is the volume, and since we are dealing with minimum material, that means our surface area must be minimal. Okay, minimum. Clear? However, take note of this. We don't we don't receive sheets of metal in circular form, correct? We don't receive sheets of metal in circular form. What we receive, or we can cut out a circle from a rectangular or square piece. Oops, too far. Okay, you get the idea?
Yes, teacher.
Even though that this is going to be waste material, okay, we cannot help it. Okay, we cannot help it. As long as what we need to aim for is that this waste material is very, very minimum. Okay, so what is now the total surface area? Okay, what is now the total surface area over here?
2 pi r times height plus
Okay, 2 pi r times height. 2 pi r times height plus,
Plus 2 times pi r squared.
assuming that we need a square to cut the circle. So this complete side is how long?
2
2r.
4
From here
r
to here.
2r
2r.
2r. Since it is a square, right? It's a square, so this is also 2r. But we need 1. How?
So 2 times 4r squared.
So 2 times 4r squared times 2. How many? 2 times
2 times 2.
2r
2 times
squared.
4. Yeah, already, teacher. 2
So
already in front.
8
8r squared.
r squared. Okay. So everyone understood how we got the total surface area?
Yes.
Yes.
Yes, okay. And our target here is to minimize this. The problem here is we cannot do anything as of now. Let's just say this is A, so that we will be working with a single variable. So A. So A. Okay. Now, we need to find another formula in order for us to remove one of these variables. Where can we, what formula can we use there? Where or what formula can we use, or what equation can we make in order to be either A or one of these? Anyone? We still have this. What's the volume of a cylinder?
pr squared times height.
Pi r squared times height, right? However, we have the volume, okay? So pi r squared height equal to
343.
343. So we can actually solve this one. Okay, we can actually solve h for this one. So h is basically 343 bagi
Squared.
pi r squared. Okay, so by substitution, we can change h with this. So continue solving.
Then the
Tell me if you are getting confused, yeah? Yeah? So we will now get A, that's the area. It's now going to be 343, 343 per pi r squared kali 2 pi r, 2 pi r, right? This one, plus 8r squared. Okay,
Yes.
simplify.
Uh,
Simplifying
8
this,
six.
we now get
3 over r.
ini, ini. So that is now going
686
to be A equal to 686 bagi
over R,
686 bagi R plus
8R
plus
squared.
8r squared. Good. Okay. So now, this is now going to be our equation for the area, Aja. And our goal is to make it minimum. Okay. Clear? This is now what we are going to work on. Oh, minimize. Okay. So what values of R can we use in order for us to produce the minimum value? Okay, so we need to get A prime, correct? A prime equal to? A prime is
16R minus
16R minus
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 686.
686 over
Minus?
R squared.
686 over R squared. Okay, and then we need to find two values. Okay, we need to find two values when this one is equal to 0. When R equal to 0. Give me two values. Come on, work on it.
So we have 0 and then we have
We'll have
that's a little bit to 0 right, teacher.
wait. No. Salah. Not R equal to 0. When A prime equal to 0. When A prime equal to 0. So what are the possible values of R? That is now squared, right? So what?
Uh, 3.5 centimeters.
You have how many values here? One value only, right?
Yeah,
Because
one.
this is a fraction, you combine it as a single fraction, so you will be ending up with r cubed, and then you get the square root, you will now get 3.5 centimeters. Now, the question is, we cannot graph this, so that we do not know if it is a positive or it is a maxima or a minima. The question now here is, we need to test this. Okay, test if this value is going to give you a maxima or minima. How do you get that? You need now your second derivative, A prime prime, from this. A prime prime with this one. What is A prime prime? Come on.
16 plus 1372 over R cubed.
1372 per
R cube.
R
Cube.
cube. Okay. Now, substitute this here. Okay. Substitute this here. And then what will you get? Positive, negative?
Positive.
A prime prime is positive, right? Positive raised to 3 is positive, so positive over positive is positive, plus 16 is now A prime prime is greater than 0. Now, interpret. A prime prime is greater than 0. What will you get?
So it's a
A
minimum.
prime prime? It is a minima, correct? So since we've proven that this size is going to give us a minimum value for the area, then this is now what we are going to recommend. We are now going to recommend to the company that to minimize waste and still give us the desired volume, then the what's it? This one is, or the radius must be 3.5 centimeters. You get the idea? So recommendation, okay, build a can or make a can with 3.5 centimeter radius. Okay? Clear? So if this is not clear, you can ask your questions later this afternoon during our second session. Okay? So right now, it's already time. You can now move to your next class. Goodbye, everyone.
Okay, teacher.
Okay. Goodbye and thank you, teacher.
Goodbye. Thank you, teacher.
Thank you, teacher.